6 is the quadratic formula and the discriminant. Today you are going to solve quadratic equations using the quadratic formula, and you're going to find the number of solutions of a quadratic equation. So we found solutions for quadratic equations by graphing. We found them by factoring, right? We found them by using the vertex and other 2 points. So here is another way that you can find the solutions of any quadratic function. Okay, so this will work for any quadratic equation. The formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. When you have an equation, okay, and it's ax squared plus bx minus c equals 0, has to be equal to 0, then you can take the a, the b, don't forget the sign, and the c. And then you can substitute those into the formula. Okay? And then that will give you your solutions. So for problem 1, we're going to use the quadratic formula to find our solutions. So here we've got x squared minus 4x is equal to 21. Now remember, it has to be equal to 0, right? So we're going to start with x squared minus 4x is equal to 21. In order to make this equal to 0, then we're just going to subtract 21 on both sides. Very good. So we've got x squared minus 4x minus 21 is equal to 0. So looking at that equation, there's our A, there's our B, and there's our C. Okay? So A is equal to 1, B is equal to negative 4, and C is equal to negative 21. And now all we do is substitute into our formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So there's your substitution. We have a negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times negative 21, all divided by 2 times 1. Okay, so here's our next step, simplified. So now we'll simplify a little more. So now, let's see. 16 plus 84 is 100. So that's going to be x. X is equal to 4 plus or minus the square root of 100 divided by 2. This is equal to 4 plus or minus 10 divided by 2. Okay, and now we just simplify. So, notice that there's a plus and there's a minus. How many solutions am I going to have? 2. Very good. So we have x is equal to 4 plus 10 divided by 2. And we have x is equal to 4 minus 10 divided by 2. So this gives me x is equal to 14 divided by 2, which is equal to 7. And then over here, x is equal to negative 6 divided by 2, which is equal to negative 3. So my two solutions for the equation are x is equal to negative 7, x is equal to positive 7, and x is equal to negative 3. All right, problem 2. When the radicand in the quadratic formula is not a perfect square, you can use a calculator to approximate the solutions of the equation. Okay? So So, problem 2 says, finding the approximate solution. A batter strikes a ball. The equation y is equal to negative 0.005 x squared plus 0.7x plus 3.5 models its path, where x is the horizontal distance in feet the ball travels and y is the height in feet of the ball. How far from the batter will the ball land? And then we want to round to the nearest tenth of a foot. All right, so when we're talking about x being the horizontal distance and y is going to be the height, if I sketch a graph, okay, this horizontal distance, well, when we start at 0, is it feet? Yeah, when we start at 0 feet away, okay, suppose the person the height is there, because you know when you throw the ball, it's going to be up here, right? It's not going to be down on the ground, right? It's going to be up here. So when they throw it, so x is the distance in feet, and y is the height. So as the ball gets further away from where it's thrown, it goes higher and then lower, right? So what happens is that the ball gets thrown, and then it's just going to land on the ground. Right there. Does everybody see that? So as the distance, at this distance, it's going to be here. That's going to be how high it is in the air. At this distance, it's going to be here. At this distance, it's going to be here. At this distance, what's the height? 0, right? So when I look at this equation, that tells me that y is going to be equal to 0, because we're looking for when is it going to land, right? Or how far will the ball land from the batter, okay? So our new equation then is 0 is equal to 0.005 x squared plus 0.7x plus 3.5. And from here, we've got our A, we've got our B, and we've got our C. So A is equal to a negative 0.005, B is equal to 0.7, and C is equal to 3.5. And now, all we have to do is substitute that information into our quadratic equation. X is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So here is the equation after we've substituted, and this is what we're going to simplify. So here we are all simplified. Now we just take the square root of 0.56, and here I'm not going to round, I'm just going to leave it in the calculator, okay? I think I'm going to have to round, okay? So I'm going to go ahead and round. And so I've got x, I'm going to write it over here, negative 0.7 plus or minus, and let's round it to the nearest hundredth because we have hundredths in our problem. So it's going to be 0.75, all divided by a negative 0.01. Okay? And now I can separate it into the addition and the subtraction. Okay? So x is equal to negative 0.7 plus 0.75 divided by a negative 0.01. And x is equal to a negative 0.7 minus 0.75 over negative 0.01. And now we just simplify that. Okay. So, there we are simplified. This is going to be a negative 5 feet, and this is going to be 145 feet. Thank you. Very good. So, that means that this one gets thrown out. So, the ball lands 145 feet from the data. So problem 3 is choosing an appropriate method. Which method or methods would you choose to solve each equation? Explain your reasoning. So letter A, we have 3x squared minus 9 is equal to 0. Okay? Now, because we have perfect squares there, we would use square roots. Okay? We would use the square root. So you're just going to solve for x, right? So we would add 9 on both sides, divide by 3, then we get x squared is equal to 3, and then take the square root of that. Okay? So the next one, x squared minus x minus 30 is equal to 0. You can solve that one by factoring, because 5 times 6 is equal to 30, right? So you can easily factor that into the two binomials and then set them equal to 0, and then get your solutions that way. 6x squared plus 13x minus 17, here we can use the quadratic formula, we can use graphing, and because the equation can't be factored. Because you cannot multiply anything to get 17 where you can add it to get 13. You see that? So this is how you're choosing which way you're going to find the solutions. Okay? The discriminant is everything under the square root. Okay? The discriminant is the b squared minus 4ac. The discriminant tells you how many solutions you're going to have. Okay? If the discriminant is greater than 0, or in other words, if it is positive, then you have 2 real number solutions. Okay? If the discriminant is equal to 0, there's 1 real number solution. And if the discriminant is less than 0, or negative, right, there are no real number solutions. All right, problem 4 is using the discriminant. For this one, we want to know how many real number solutions does 6x squared minus 5x equal 7 have? We want to know how many solutions there are. You think 2? You think? I think 1. Anybody else? 7. Going once? Going twice? 3? 3. Okay. 8?
No solution.
No solution? Okay, let's check it out. All right, so we've got 6x squared minus 5x is equal to 7. Now remember, before we use the quadratic equation, it has to be set equal to 0. Okay, so we're going to subtract 7 on both sides. We get 6x squared minus 5x minus 7 is equal to 0. So A is equal to 6, B is equal to negative 5, and C is equal to negative 7. So the discriminant is just everything under the square root, right? So under the square root is the b squared minus 4ac. This is the discriminant. Okay. So now we substitute in. So this, we've got b squared, so that's a negative 5 squared minus 4 times a, which is 6, times c, which is negative 7. So we've got 25 This is going to be plus 168. Very good. So that gives me 193. So my discriminant is positive. Right? So how many solutions do I have? 2 solutions. Therefore, 2 solutions. Do I know what the 2 solutions are right now?
Yes.
No, I do not. I only know that there are 2 of them. And if I wanted to find out what the 2 solutions are, then I would have to use the entire quadratic equation.